All right, let's dive right into this explainer and discover the invisible foundation of our modern society. The things we depend on the absolute most are usually the ones we think about the absolute least, simply because they're hidden right in plain sight.
So, let me ask you something. What connects your morning toothpaste, the food sitting on your plate, and a massive moving train? Sounds kind of like a riddle, right? Well, the answer actually unlocks a huge fundamental truth about human civilization.
The answer? Mined resources. Yep, your everyday life is completely, 100% dependent on geology. Think about it. That toothpaste cleans your teeth using silica, and it gets that little shine from a mineral called mica. When we eat, the nutrients in our food, they're unlocked by trace minerals. And that high-speed train moving millions of people around literally couldn't exist without extracted iron, aluminum, and fuel. Every single thing we do is built right on top of the Earth's crust.
So here's our agenda for this explainer. We'll start with minerals in everyday life, move on to defining exactly what Earth's minerals are, then we'll look at where they hide, how we classify these resources, and finally we'll wrap up with India's massive mineral wealth.
All right, Part 1, Minerals in Everyday Life, Hidden in Plain Sight.
It is actually mind-blowing how many distinct Earth elements it takes just to brush your teeth in the morning. Seriously, let's look at the anatomy of a bright smile here. You've got fluorite, which provides cavity-fighting fluoride. Then you need rutile and ilmenite to get the titanium oxide that actually makes the paste white. Mica gets added in for that satisfying little sparkle you see. Oh, and the tube holding the whole shebang together? Made of plastics derived from petroleum. So every single time you're standing at your bathroom sink, you are holding the results of a global mining operation right in your hand. Pretty wild, right?
And hey, it is not just the tools we use, it's our actual biology. Check this out, 0.3%. That tiny fraction is the total amount of our food intake that consists of minerals, just a fraction of a percent. But here's the crazy part. Without that tiny 0.3%, our bodies literally could not process or use the other 99.7% of the nutrients we consume. They're basically the essential chemical keys that unlock all our nutrition.
Moving on to Part 2, Defining Earth's Minerals. What exactly is a mineral? So, scientifically speaking, a mineral is a homogeneous, naturally occurring substance with a definable internal structure. Basically, that means it's consistent all the way through, it has a very specific atomic makeup, and, crucially, it's made by nature, not cooked up in some lab. But nature, as we know, is incredibly creative, and that is exactly why these substances show up in such wildly varied forms. We're talking everything from the absolute hardest diamond to the softest talc.
Now, depending on who you ask, you are going to get a totally different perspective on these substances. Geographers? Well, they focus on the macro. They look at landforms, how minerals are spread out across a map, and the economic activities they bring to a region. But geologists, on the other hand, they focus on the micro and the historical side of things. They want to know how a mineral was actually formed, its exact age, and its physical and chemical composition. So two different but equally vital professional lenses used to study the Earth's crust.
Okay, Part 3. Where do minerals hide? Finding Earth's resources.
So the Earth basically has 5 primary natural ways of manufacturing all these resources. First up, we've got igneous and metamorphic rocks. This is where liquid and gas literally force their way through cracks, cooling into smaller veins and larger lodes. This is what gives us metals like copper and zinc. Second, we have sedimentary beds, where heat, pressure, or evaporation over super long periods create these horizontal layers of things like coal or gypsum. Third is the weathering of surface rocks. Basically, water washes away the soluble parts and leaves behind a residual mass of valuable ore, like bauxite. Fourth, we have placer deposits. These are heavy, water-resistant metals, think gold and platinum, that just settle in the sands at the base of hills. And finally, step 5, the vast ocean waters which hold just enormous quantities of diffused salt, magnesium, and manganese nodules.
Now, extracting all these resources isn't always some massive state-run corporate endeavor. Take Meghalaya, for example, a state in northeast India. While most Indian minerals are nationalized, tribal areas there actually have community-owned deposits. And according to the source, coal mining is done by family members in the form of a long, narrow tunnel, which is known as rat hole mining. It is a really surprising fact about local community extraction. Though I should definitely note, the National Green Tribunal declared these specific activities illegal to protect the environment. Still, it just goes to show how incredibly varied the human approach to geology can be.
Let's move to Part 4, Classifying Our Resources, the Mineral Family Tree.
To make sense of all this, we actually organize minerals into a sort of family tree with three main branches: metallic, non-metallic, and energy minerals. Under metallic, it gets further divided into ferrous, which, simply put, just means it contains iron. Non-ferrous, like copper and bauxite, and then your precious metals like gold and silver. Having this clear structure absolutely anchors our understanding as we start our upcoming geographic exploration.
Which brings us to Part 5, India's Mineral Wealth, an Uneven Distribution.
When it comes to India's mineral wealth, geography essentially dictates destiny, and it is incredibly uneven. The ancient peninsula rocks down in the south and center, they hold most of the coal and metal reserves. The sedimentary flanks over in the west and east hold the petroleum, but those vast northern plains, basically entirely devoid of economic minerals. This uneven distribution is absolutely crucial because it dictates exactly where mines can actually turn a profit, all based on the ore concentration and how easy it is to dig up and bring to market.
To really grasp how concentrated this is, consider a staggering number: 97%. In the year 2018 to 2019, almost all of India's massive iron ore production came from just 4 states. Just 4: Odisha, Chhattisgarh, Karnataka, and Jharkhand. That leaves a measly 3% of production for the rest of the entire country.
Now, there's also some really charming cultural trivia behind this geography. The hills that produce this vital iron ore actually often get their local names from their distinct geological shapes. For instance, Kudramukh in Karnataka literally translates to horseface in Kannada, simply because the highest peak looks exactly like one. And the immensely productive Beladilla Range in Chhattisgarh, it gets its name because the hills look just like the hump of an ox. It is such a wonderful human element attached to these massively productive industrial regions.
When we look at bauxite, which is the clay-like substance that gives us aluminum, one state absolutely dominates. Odisha produces an overwhelming 65% of India's bauxite, completely dwarfing Jharkhand, Gujarat, and the others. And aluminum is highly prized because it combines the strength of iron with extreme lightness. Honestly, without Odisha's unique geological weathering, India wouldn't have the aluminum needed for its modern construction and aerospace industries.
Finally, we've got to talk about the magic of mica. This non-metallic mineral is just incredible. It splits easily into thousands of ultra-thin sheets, but more importantly, it possesses unbelievable insulating properties, low power loss, and resistance to high voltage. Because of all that, mica is completely indispensable for our electronic and electrical industries. And the leading producer? The Chota Nagpur Plateau in Jharkhand. They're providing this vital resource that is very likely powering the device you're using to listen to this right now.
So we've gone from the macro geography of India right back to your everyday life. I want to end this explainer with a little challenge for you. Look around your room right now. Seriously, look around. What unseen minerals are making your modern life possible at this exact second? Is there bauxite in your window frame? Maybe some mica inside your smartphone? Coal powering your overhead lights? We literally build our lives out of the Earth's crust. Think about that the next time you brush your teeth. Thanks so much for learning with me today, and keep exploring the invisible foundations around you.